Welcome. In this video, we will dive into the concept of ZK rollups, a revolutionary scaling solution for blockchain networks. ZK rollups leverage zero-knowledge proofs to enhance both scalability and privacy, allowing faster transaction processing and lower gas fee while maintaining security and decentralization. ZK rollups employ a two-phase process to achieve scalability. First, transactions are processed off-chain and blended together in batch. This allows for efficient parallel processing, increasing transaction throughput. Next, zero-knowledge proof is generated for the entire batch, proving the validity of all transactions without revealing their content. This proof is then submitted to main chain for verification, which is faster and cheaper than individually validating each transaction. To develop ZK rollups, you need to set up the development environment. First, installing Node.js, a JavaScript runtime environment. Choose a development framework like Truffle or Hardhat. Then Next, install the zkSync SDK using npm or yarn and configure your environment with the necessary settings and dependencies. Before starting ZK rollup development, ensure you have installed Node.js, Truffle or Hardhat, and the zkSync SDK. These tools are essential for building and deploying ZK rollup contract. For instance, you can install the zkSync SDK with the command npm install zkSync. These installations simplify the development process and provide the necessary building blocks for your ZK rollup application. So this is the code I told you, npm install g zkSync. Through this you can install the SDK. Now, to create a new ZK rollup project, start by creating a new directory and initializing a Truffle project. Use mkdir ZK rollup project to create the directory and change directory to navigate into it. Then run truffle init to set up the basic project structure, which includes configuration files and a sample smart contract. Then a ZK rollup contract defines core functionalities such as managing user balances and tracking deposit and withdrawals. Key functions include deposit and withdraw, which handle adding and reclaiming funds. Events are declared to monitor these transactions, ensuring transparency and accountability. Let's look at an example ZK rollup contract in Solidity. This contract has a mapping to store balances and events for deposit and withdrawals. The deposit functions allows user to add funds, while the withdraw function lets them reclaim funds, ensuring they have sufficient balance before processing. To deploy ZK rollup contract, compile it using Truffle compile. This converts the human readable code into a bytecode for the blockchain. Then deploy the smart contract to a testnet like Ropsten using Truffle migrate dash network Ropsten. Verify the deployment by checking the contract address and transaction hash. To interact with the deployed contract, connect to it using the Web3 library. Here's a simple example of connect, deposit, and withdraw of funds. This involves installing Web3, defines the contract, ABI, and address, and using Web3 methods to send transactions. Now we'll look at the example code I'm talking about. So this is the example code I'm talking for this function. Using the Web3, we can create two asynchronous functions, which are deposit and withdraw, and we can do the ABI workflow. Zero-knowledge proofs are used in ZK rollups to verify transactions without revealing data. Choose a ZKP library like zkSync SDK, define the proof statement, generate the proof, and encode it for submission to the main chain. This ensures the integrity and privacy of transactions. This is an example code of how we can do it. The asynchronous function of the generate proofs do the work. Now, verifier contracts on the main chain are responsible for validating zero-knowledge proofs submitted by the rollup contract. The rollup with proofs contract demonstrates integrating a verifier to ensure that withdrawals are authorized with valid proofs. Let's see at the code with rollup with proofs. The code snippet will illustrate a simplified implementation of ZK verifier contract, and the rollup contract demonstrates how to integrate a ZK verifier into a ZK rollup system, and then we will integrate and use it. So here is the code we will be using. This is a very basic code. Here we define a contract ZK verifier with a function in it and another contract with rollup with proofs, as I talked earlier about it. The roll-up with proofs contract demonstrate integrating a verifier to ensure that withdrawals are authorized with valid proofs. And here are the another two functions which are deposit and withdraw. Now, managing deposits and withdrawal is crucial in ZK rollups. Users deposit funds on-chain, transact off-chain, and withdraw funds back on-chain using zero-knowledge proofs to verify transaction validity. As I told you, first they deposit on-chain, then transact off-chain, and then again on-chain. So this is the third step on-chain. Connecting to a ZK rollup network involves setting up your development environment with the necessary libraries and configuring network credentials. Now we will look at an example of connecting to ZK Sync. For that, we will have to install the dependencies, and once the connection is established, we can start the ZK rollup network. So the code we will be looking at to connect to the ZK Sync will have the ZK Sync provider class, which provides a connection to the ZK Sync network, and a connection code which shows how to connect to the ZK Sync network. And last will be the testing and verification of the code. So this is the code we will be using, which I am talking about. It sets up a provider for the Rinkiby test network and creates a wallet using a private key. And don't forget to plug in your actual private key instead of your private key, and logs the Ethereum address of the connected wallet. This is a foundational set or step for integrating with ZK Sync, allowing you to perform various operations like deposit, withdrawals, and transaction within the ZK Sync ecosystem. Monitoring ZK rollups transaction ensures transparency and aids in debugging. Tools like ZK Sync and Block Scout provide high insight into transaction activity and network performance. Security is paramount in ZK rollup development. Thoroughly audit smart contracts, validate zero knowledge proofs, and follow best practices to prevent vulnerability and ensure the safety of user funds. Adopt secure coding practices, conduct regular audits, and implement comprehensive testing strategies. This ensures the robustness and functionality of your ZK rollup system. For testing and debugging, first set up the testing frameworks like Hard Hat or Truffle or Foundry, and then writing the test cases and then debugging the common issues you are facing. The future of ZK rollups include enhanced proof generation, better layer 1 integration, and increased adoption in various applications like DeFi, gaming, and identity management. Ongoing research and development will continue to improve ZK rollups, scalability, security, and usability. ZK rollups are transforming industries by offering scalable solutions. From decentralized finance to gaming, the potential applications are vast and continue to grow. Embracing ZK rollups technology can lead to innovative and efficient blockchain solutions. Thank you for watching this video on ZK rollups. We covered their fundamentals, development process, and future potential. If you have any questions or need further information, feel free to reach out. Have a great day.